Hello everyone. In this deep dive video, we are going to take a closer look at the point cloud import capabilities within InStep Studio. This capability was requested by some users in the past that wanted to directly import their 3D scan data into the application without having to use a third-party application in between. Prior to importing a file, make sure that the option is turned on to show messages. That will provide a small amount of feedback during the import. You can load a file just like any other. You go to Open and then you select the XYZ format and then you pick your file. As soon as the file's finished importing, which will generally only take a few seconds, the application will then show the point data. In this case, it's important to point out that this file that we loaded does not contain normals. So normals, for anyone that's interested, is a vector that points away from the surface. So a scanner would normally calculate the direction of the surface pointing away from where it registers a point, and it'll store that in the file. The XYZ files in this case are just a collection of 6 floating point values, so XYZ, and then a normal component for XYZ. If it only contains the point location, then the InStep Studio application does require that those normals are first calculated, and it does provide a few tools that we're going to cover in this video. However, it's generally recommended that you use other applications to calculate those points. Tools such as MeshLab, for example, are very good at doing that, and they're far superior in that aspect. They're also focused on doing just that. In this case, what we can do is we can go to the settings, which is a specific setting for the point cloud options, and we can see that there's different ways of showing the data. So it's set by default to points and normals. We can also show just points, and we can also show voxels for the case of where only points are loaded. And the voxel is just in this case a cube that is centered at that point with a size based on how far away the next point is. Triangles require that the normals are calculated, and we're going to cover that in a second. If we don't have normals, there's a few options that we can use to estimate those. The chunky algorithm is sort of hit and miss. You can give that a try, but generally, if you know that the data is centered at a point, so for example, if you're scanning a football or something similar, then you know that the points will always have a normal that goes away from the center of the data. So that would be the barycenter option. If you're scanning a flat surface, maybe a face or something, then you can either pick positive or negative coordinates to define the normal. The LS plane or least square plane and least square sphere options will go in and actually compute a plane around each point based on number of neighbors, and then it'll calculate the normal based on that. Those are generally quite robust algorithms, and we're going to use the least square plane option here. Below this are the different algorithms for then computing the point to surface, but we'll cover those in a second. So with this set, close the dialog, and we're going to leave neighbors at 10, and we're going to click estimate normals. So in this case, the calculation takes about a minute, minute and a half, and once it's done, we can now see a line pointing away from all the point data that we originally had. We can also change this display to use triangles now that we know the normals. And the triangle option, once it's selected, will take another minute or so to update. We can change the size, and we're just going to set this to 1. And that will prompt the update to run in the background. So once that update completes, we can now see that there's something resembling a surface, but on closer inspection you can just see that these are loose triangles. So this isn't an actual surface, it's just triangles being placed where the points were. But what's important is that we don't have large sections that are darkened, so a darkened surface would be the equivalent of looking at it from the inside. So for this case, this looks fine, and we can go ahead and convert this data into a surface. So we click the settings, and now we can pick one of the three available generators. So for this case, I'm just going to leave it at Poisson. The Poisson has a number of options, but these generally work fairly well at their defaults. So we're going to leave that as is, close this dialog, and then click Preview. Once this process completes, the display will update and we'll be left with a body consisting of all the surfaces that were just generated. We can show the edges, and we can take closer inspection at the underlying data. And in this case, this looks quite good, and this would generally be useful. We're going to go ahead and change the settings to a different method. So again, we click on Settings, and then we're going to change the surface generator from Poisson to the Reconstruct 3D. The Reconstruct 3D has a few options again. One to point out is the surface resolution. So in this case, it's set to R64, or a resolution of 64 blocks based on the largest side of a bounding box for the data. I'm going to leave this at its current state for now, and we can change this up to 1024, but I usually want to leave this as a small number to start and then gradually increase. So we're going to leave these as is, close, and then again click Preview to update. Once the update completes, and generally this will be fairly quick for a small number, we'll see that the resultant data is actually not what we're looking for. This is purely because of the number of divisions being relatively small. So we can go into Settings again, and then pick a higher resolution. So in this case, we'll just switch it to 256. Now obviously the higher this number, the more memory it consumes and the longer this will take. But we'll click Preview. And after a few seconds, we see the updated model. In this case, this would look fine, and we could use that as is. We could also go in and try the lower resolution or higher resolution just to see how those compare. The last option I want to try is the smooth sign distance option. So again, we click on Settings, and then from the method we pick the smooth sign distance option. Again, a number of options here, and we can change these to see about changes to the output, but generally these should be okay. So we'll leave those as is, close that, and update the surface. The result of this looks fairly good. So again, this would be a perfectly acceptable result. Take a look at the edges, get some more detail there. That all looks fine. So once we're happy with that, we can click Apply and convert that into a surface. Once the application shows ready, it might be that the display doesn't update exactly, so we can just move the mouse and that will update the body. In this case, it resulted in 111,000 features, so that's generally fairly large, but it's a good starting point for other processes. One item to point out is that during the process of converting these surfaces, the application actually creates temporary files locally. In order to change where those files are located, we can go to Settings, Application Settings, and then scroll down and look for the working directory, in this case here. By default, this will go to ctemp instep. The reason for that is you want to keep the path relatively short, just because large file names can be created beyond this, and there's a built-in limit to how many characters can be used. It's also important that the directory does not contain special characters or other things. So if you can use this location, it's recommended that you use this. Taking a final look at this data, the next likely step would be that we first try and bring down the number of features from 111,000 to something a little bit more manageable. So the way you would do this would be to go to Bodies and then pick the Simplify tool, set a target value. In this case, I'm just going to leave it at 10,000. Use the preview option to get a first look at what that's going to result in. And if necessary, turn on the edge display to get a better look at the resultant body. Once we're happy with that, we can go ahead, click apply, and make that change permanent. And that concludes the deep dive on the point cloud import option.